Hi, good morning friends. Welcome to BI Welcome to Data and Dimensional Modeling course. Today we will cover the introduction part. In this we will cover a little bit introduction about the course, and we will cover the curriculum part, the syllabus part, which we are going to cover in the next few classes. So let us start with this introduction, that why we are launching this course, why we have launched this course. Basically, data modeling is an important aspect of any database building exercise. So whether you are creating in software application for retail or domain, or for telecom domain, or for finance, or for any other domain, you need to have some kind of database, and most of the time it is relational database. And what we do before creating a database, we have to have some kind of data model in place where we can we can gather the requirement, we can fine tune it, and then finally we go and create a database based on that data model. So data model is very important exercise. And then comes dimensional modeling. So dimensional modeling is used for data warehouse development, which is similar to data modeling, but there are some specific techniques or some specific concepts which are different from data modeling. So for example, in data modeling, in normal relational database management, you have to do normalization, and but in data warehouse development, this rule is relaxed a bit, and based on the requirement, sometimes you don't go for normalization, you in fact do denormalization sometime. So there are a lot of data warehousing related aspects which would be covered in dimensional modeling. So in spite of these two very important aspects of database and data warehouse development, we hardly have any formal training available on this in anywhere, whether in the colleges or whether in the institutes. So BIB thought to start this course, and our aim is to equip the learner with practical knowledge with all theoretical aspects about these two subjects. So what we are going to cover in this course is, as I said, the data modeling part, where we will discuss about the data modeling, all the basics of data modeling, how we build data models, what type of data models, and then we'll talk about normalization, we'll talk about entity relationship, we'll talk about subtype, supertype. So these are all basic stuff which we will cover. We will talk about conceptual data model in detail, how we create conceptual data model, what is the importance of conceptual data model, what are the reasons to create conceptual data model. We'll move on to logical data model, why we need logical data model, what are the things which are different in logical data model from conceptual data model, and how what are the techniques to have a good logical data model. We'll move on to physical data model, wherein we will discuss about lot of things which you need to take care when you create a physical data model, and lot of inputs which are required to create a physical data model. You cannot just simply go and create databases, but based on the requirement, based on technical requirements, based on business requirements, there has to be some tweaking required in the physical database, which you have to do and you have to take care when you do physical data model. Then we will talk about dimensional modeling. So what is the dimensional modeling, what are the benefits of dimensional modeling, how can we compare it with ER modeling, we'll talk about fact tables, we'll talk about dimensional tables. Then we'll talk about a lot of advanced topics of dimensions, like confirmed dimensions or degenerate dimensions or junk dimensions, and what role they play in data warehouse development. We'll talk about a very important dimension, which is date and time dimension, which play a great role, and we have to have some special consideration for date dimensions. Okay, we will talk about the null attributes in dimensions and how we treat null. This is very interesting. So null are treated differently in data warehouse than in online transactional processing system. We'll talk about some other advanced topic like hot swappable dimensions, audit dimensions, and what happens when dimension record is arriving late and fact is coming first. So how you deal with that data integrity problem, how you manage that in data warehouse, and that we face this problem lot of time. It is not like one-off problem. In fact, in normalized databases or in OLTP databases, you will not have this problem so often. But in data warehouse, we know that we are going to have this problem, and we already have a solution for that. We'll talk about bus architecture, which is to connect all dimensions, all fact tables, which is to create an enterprise view of a data warehouse. And then we will talk about slowly changing dimensions. And as you can see, there are now type 0 to type 7. So there are this total 8 types. And earlier we generally used to talk about 3 types: type 1, type 2, type 3. But now the new standard which is coming up, which has 8 types. Okay, we will talk about snowflakes. We will talk about star schema, snowflakes, outriggers, hierarchy, and bridge tables. Okay, so how the outriggers can be used, to solve some problems. How bridge table can be used to solve many to many relationship problem, and how we implement hierarchy from data warehouse side, and what we do with, and what type of hierarchies are there, and how we implement those type of hierarchies. We'll talk about facts in detail. So there are basically 3 type of facts: transition fact tables, periodic snapshot fact tables, and accumulating snapshot fact table. We'll talk about all these fact tables. Again, we will talk about many advanced topics on facts. For example, the fact table surrogate keys. So you might have heard about dimension table surrogate keys, but we have surrogate keys on fact tables also. And then we'll talk about some common topics like factless fact tables in detail, and we'll talk about some advanced topics like centipede fact tables. We'll talk about those fact tables in details, like what are the properties of those fact tables, how you define the grain of the fact table, and in which scenario you need snapshot fact tables, and and what are the properties of those snapshot fact tables. We'll talk about the accumulating snapshot fact tables, and what is the need of that in accumulating snapshot fact tables in the data warehouse. We'll talk, as I said, we talk about factless fact tables in detail, and then we will talk about this, how a single fact table is needed for each process. So if, let's say, there is a process, you cannot have multiple fact tables for that process, and you cannot also have one fact table for multiple processes. So that is not a good design. You need to have a fact table for each process, and how you decide that this thing is a single process, and I need to have this one fact table for this process. So we will talk about those things. This is basically a design strategy. We'll talk about detail of confirmed dimensions. So confirmed dimensions are very, very important in data warehouse, and the entire data warehouse architecture is based on confirmed dimensions when you talk about enterprise data warehouse, and we will talk about that in detail. Then there are some advanced topics. So we will not leave any advanced topics on dimension tables. So that there is a test there, and there is a topic how you can combine or group dimension tables, how you need to break dimension tables. You cannot have them in one table. Okay. Again, how you deal with invalid data, or how you deal with historic facts, how you categorize facts and create dimensions out of the facts. Then how you deal with hierarchies, how you cross between dimensions, how you do drilling, and what are the different methods for drilling. okay, how you document these activities. Then we'll talk about multi-value dimensions and bridges. So basically, some dimensions might be multi-valued. So basically, multi-valued attributes are not allowed in normalization, but in data warehouse they are allowed. So, but we cannot just have them in data warehouse, because that will create a lot of problems. So they have, we have come up with it, or data warehouse, as per data warehousing architecture, the designer have come up with this concept of bridge table, which you can use for to avoid or to resolve the problems created by multi-valued attribute dimensions or multi-valued attributes. Then you have, lot of times we want to have generic hierarchy. For that, we need to have recursive hierarchies, and we need to also have bridge tables to resolve some of the problems created by that. So in this topic, we are going to talk about type specific stars. So in some cases, what we do, we create a single star which work like a code star, and then we have some sub stars which works like a subtype, or the custom fact tables. So here we talk about type specific star. So in this we would identify if we can create a core star, and then we create a custom star to avoid some kind of redundancy, or to avoid some kind of problem. For example, let's say you have a company, telecom company, wherein you have a lot of business units. So you have one business unit for wireline connections, so you have one business unit for mobile connections, you have one business unit for internet connection, and the customers are coming from all these departments, and they are coming with their specific attribute related to that department. But then finally, when you club all of them in one big customer table, you have so many attributes, which and most of them they belong to their own department. So what you do in that case, you create a one core customer table, and then you store only common attributes in that, and then you create a separate customer table for each department, and then you have attributes related to that department in those department specific or business unit specific tables, right? So this approach is called custom and core star approach, and we also have fact tables like that. So I will talk about those fact tables, dimension tables, and custom and core stars. Then we'll talk about derived schema. So basically, the derived schema is very important for data warehousing, because they are used to first improve the performance, and they are also used for a lot of calculations, lot of report specific requirements, that report wants some data in some certain way, and that cannot be done in the ETL side or in the data warehousing side. So we create a derived view, for example. Okay, they are also used for cubes, right? So for example, you can see we create pivoted fact tables, we create slice fact tables, right? So why we create slice fact tables? What are the use of slice fact tables? Another important thing for performance improvement is aggregates. So why we create aggregates? What we do when we want to create aggregates, and how we load aggregates? Based on the requirements, how we can get the aggregated data from for different requirements. So for example, you have a retail company wherein you are getting data for each, whenever a customer walks in and buys something, they do billing. So every billing is a data generated. So like that, for the full day there might be a lot of data generated, but you want only you are a manager of the store, and you want only to see the total sum value of your store. So you just might want to aggregate them in the night time, and when in the morning you come back, you see the last day's sales value, and that will be just like a one row in the table. you don't have to run that query for the full database, and because that would take another 4 hours. But that can be automated, and that can be run in the night time, which it might take 4 or 5 hours, but the result is ready in the morning for you. So that aggregate is very powerful feature or technique in data warehousing. We use a lot of time, and there are tools where we can, when we are trying to fire a query, the tool will decide that where you have your aggregated data, and based on that it will go to that table and fetch that data. So all that is called aggregate navigation. Okay, so we will discuss all these things in detail. Then we will discuss about how to design a dimensional model. We will discuss about the prerequisite part, we will discuss about the requirements part, then we will discuss about what are the modeling tools available, other important aspects like naming conventions, and how to do source data profiling, how to obtain, how to do project planning. Then there is a 4-step modeling process, how to design the database dimensional model, how to create a high-level dimensional model, then how to go into detail into find out the specific, how to identify the sources, how to consolidate the data sources, how to establish the confirmed dimensions. So all these we are going to discuss in this course, and then we will discuss about a real project checklist, the data model and dimensional model project checklist, where we will see what are the different inputs required, what are the items we need to take care, and how we will see a real life. I will bring to you a real life project on dimensional modeling, and we can see the document part of that, and we can discuss what are the different things required for dimensional modeling or data modeling. Okay, then we have a project in this course. That project we will build on eRWIN Community Edition. And so what we will do is we will guide you how to download and install eRWIN. We will also guide you to download an open source database, and you can connect that database to eRWIN, and then you will have a guide. We will also provide you data mart specification. There will be a small data mart specification wherein you have to create some dimension tables and some fact tables, and you can create those tables on eRWIN, right? And from eRWIN you can connect to any database, or you can connect to this database which we will guide you to download and install, that is MySQL. Or you can connect it to any database which you have. You might be having an Oracle or MS SQL server, so you can connect this eRWIN model to any database, and you can execute and run the data DDL schema, and it will create those tables on database directly. So your eRWIN will create those tables on database. You don't have to create those tables on database manually, but eRWIN will do that. So all these things we will discuss, and we will give you an instruction sheet wherein you can do this project at your end, and then we will discuss, if you are not able to do it, or if you want some guidance, or if you want some further help, then we will discuss about that. Okay. Then we will have a we will have 2 case studies, and the first one will be retail data model case study, where we discuss about industry standard retail data model, which is coming from the company which is into database software for lot of many decades, and they have got some very good experience on retail data modeling. So they have come up with a retail data model, a generic model of retail data model, and then they share it with the community, and we can see that we will discuss about that what are the different entities, what are the things which happens in retail domain, and how we can design various dimensions or stars or other tables. We can decide how to design them into into retail environment. So you can actually take that data model with you, and if you want to implement any data model or dimension model for any retail company, you can actually use that, and you can use that for your project. You can, and then you can customize it as per your retail company's requirement. So we will discuss this data model, and we will discuss about it telecom data model. That will be we will discuss that in detail. We will discuss about the data architecture and all the processes which are used in that telecom data model, and that data model will be from a real life project, and we will discuss and we will see what are the complexities of a telecom project or telecom operations, and how to deal with those complexities, and how we are using all dimensions or all techniques like slowly changing dimensions, or how we are using subtyping, supertyping. So all those things we can see live there. Okay, and then finally we will discuss about all the questions which you might have, and these questions we will discuss in a live fashion. So when we are giving a session to you, which are online session, when we are talking to you, you can always ask any question. You can interrupt us and you can ask any question from your side, and we will discuss that online at the same time. It will be an interactive session. So you might have any question in the last, or you might want to ask anything later. Then we will be having some groups where you can discuss those things, or you can directly send your query to trainer. So trainer will reply to that, or you are always welcome to call the trainer or the faculty and talk to them, and discuss all your questions or all your doubts. So welcome to this course, and very nice having you here, and we wish you all the best. We wish you a great learning journey with BI Wish. Thanks a lot.